This is the quarterly update for collaborative code competition. So prior research has shown that students who learn material in undergraduate STEM courses in a collaborative setting develop better critical thinking skills, and we've also been shown that people hold negative stereotypes about effective programmers working alone. And so kind of the motivation behind collaborative code competitions is trying to answer the question of whether we can create a platform that structures coding challenges in such a way that teams complete them, where the people in the teams work together and depend on each other to come up with the solutions to these problems, to not only help them develop critical thinking skills more effectively, but also to kind of promote healthy attitudes toward collaborative coding. So our two main research questions for this study or for this project were, will beginner to intermediate programmers view collaboration in a more positive way if they're made to complete a programming challenge, which is by design unable to be completed by a single person, and is a programmer any more or less likely to view collaboration in a more positive way if she's paired with a programmer whose skill level is greater than, equal to, or less than her own? And then within this question, there are also the sub-questions about how differences in skill level affect the amount of collaboration which happens. So in the need finding process, we looked at kind of existing solutions for programming challenges. So these are platforms like HackerRank and Codecademy, and games which were tailored toward computer science education. And what we found was that all these tasks and all these platforms, they gave you the ability to kind of complete these challenges, but they were all meant to be completed individually, so there was no collaborative aspect to it. So the prototype we developed was based in GoMix, which is a web-based collaborative editor. These essentials included a README, it had a test cases page, and it had some files with just empty functions that allowed users to implement those functions to complete the challenge. So in the early stages of the prototype, we found a few things that didn't work. Number one was I had kind of an assumption about what beginner programmers knew and what things they were really familiar with, specifically JavaScript objects. And what we found was that people actually were not as familiar with these things as we mistakenly assumed. And that players would be completing these programming challenges and wouldn't be able to finish because they just didn't know how to word questions in such a way that they were answerable through a Google search or something. So to avoid the possibility of this kind of roadblock tainting the user's perceptions of collaborative coding, because it's not really the collaboration that's failing them in that aspect, the challenge was switched to focus from JavaScript objects onto arrays, which is a more commonly taught topic in computer science classes. Early versions of this prototype also had up to 4 people working together, and this was just way too much, or way too many people. People often broke off into teams of 2 within the teams of 4, and it was hard for 4 people to work on one file and kind of like contribute. And so, yeah, like I mentioned, we switched over to array-based problems, and studies were run with participants completing the challenge in teams of 2 down from teams of 4. So this is a quick demo of GoMix. Basically, you come into GoMix and you can see this README. This details the problem and kind of tells you what you're responsible for implementing. Server.js is just a very basic boilerplate that serves up your website. And then there are these functions which, when they're handed to the players, are empty. They're meant for the players to fill out. And then some test cases to run against those functions. And then this is the test cases page, which can be launched by clicking this button. This is the page that players will reference. It gives you it shows you the 2 functions that you're responsible for completing. It also lists a couple of test cases with inputs, expected values, and what your function got, or what your function returned. So with this prototype, we were able to run a study. In this study, participants were recruited from an email that we sent out to students in EECS 330, HCI. These students provided information on how they rated their own experience level with programming from beginner, intermediate, and advanced. And we selected 8 students. So these students were placed into teams of 2, so 4 teams total. Each was asked to work together to solve a programming problem, the Connect 401 I just showed, where only one player was allowed to type executable code at a time. But all players were allowed to communicate freely and use whatever resources they needed to solve the problem throughout the challenge. So the two of the teams consisted of players that were both intermediate level programmers, self-described intermediate level programmers, while the other 2 teams consisted of 1 intermediate and 1 beginner player. Around the actual coding challenge, participants were given a pre and a post-test survey. These 2 surveys had some of the same questions meant to measure their attitudes toward collaborative coding before they participated in the study and after they participated in the study to track how it changed. And so these common questions were asked as a statement, and the user had to come back and say how much they agreed with it on a scale of strongly disagree to strongly agree. When we went back and analyzed the data, we converted this into numbers so that strongly disagree was a 1 and strongly agree was a 7. So basically the rules of the challenge were, for the first 10 minutes, both players just read the prompt and talk about how they want to approach the problem. No one is allowed to start typing at this point. Once that time has passed and they feel confident moving forward, the first player gets to start typing. In the intermediate pairs, this player was selected kind of arbitrarily, while in the beginner-intermediate pairs, the beginner player was chosen to go first. And then after the first player had been typing for 10 minutes, that player then had to stop, and then the second player got to start typing, while the first player was now in this role of kind of like a helper. This kind of like switching off again and again happened in 10-minute intervals until the challenge was completed, which happened when all the test cases passed. So a few of our core findings. Number 1, so although none of these challenges are statistically significant so far because we only had 8 participants, we did find that participants were more likely to agree with statements about the benefits of working together while coding, and were more likely to disagree with statements that had negative ideas about collaborative coding. Participants were no more or less likely to explicitly prefer coding with another person to coding alone, although this is something that we'll revisit in core finding number 2. Trends in agreement and disagreement with statements changed across pairings, the most notable being intermediates paired with beginners tended to agree more with the statement that they preferred coding alone to coding with other people, while beginners paired with intermediates tended to disagree more. And so if you look at just the data from intermediate pairings and from beginners who were in beginner-intermediate pairs, all members of those groups tended to prefer coding with another person after participating in the challenge. The only people who preferred coding alone more after participating in the challenge were intermediates who were paired with a beginner. So yeah, a similar trend also occurred in the statements, I solve problems more quickly when I work with others, and I understand problems better when I work through them with others. Another part of this finding was that intermediates paired with beginners talked for about twice as long, for about 16% of the time on average during the testing session as their partner did, so the beginners talked for about 9% of the time on average. However, these intermediates talked for the same time as other intermediates in intermediate pairs, which was also about 16% of the time on average. So some next steps we're definitely looking to develop a higher fidelity prototype that allows the game structure to be kind of baked into the editor, automated, so that you don't need a person calling time every 10 minutes. And we'd also like to perform more user testing with participants of varying experience levels. We didn't have any beginner pairings or any pairings at all with advanced or self-proclaimed advanced users. And then obviously we would also want to just run more tests so that our results become statistically significant and we can kind of pin down the effects of our system. So this is the appendix. I'm not really going to talk over this. I'm just going to like let this run because there are some charts and I think they are very useful to look at, but they're kind of self-explanatory. So this kind of runs through the core findings that I just talked about in a finer grain.